Alright guys, welcome back to the videos for cumulative review number 15. We're starting here with number 4, which is another equation, this time with U substitution, to continue the equation theme. So to start U substitution, usually you want to take out something that's a pain to put something in that's easier. And I notice we have x to the 2/5 and x to the 1/5. Usually the b term helps us the most. So if we call u x to the 1/5 power, if you think about exponent rules, if we raise 1/5 to the second power, so I'll erase this in a second, but if we said this to the second power, we multiply these exponents. So then that would really be to the 2/5 power. So that means that if I replace x to the 1/5 with u, that means x to the 2/5 is really u squared, which is why U substitution works, because it makes it easier for us to work with. So I'm going to erase that, but I did that just for understanding. So now I'm going to write the equation down here more simply. We have 8u squared minus 10u minus 3 equals 0. And if we'd like to factor this, we do not have a lead coefficient of 1, which means that we have to use split the middle term. Or you could guess and check. I know some of you prefer that. So you would take a times c and get negative 24. Figure out what pair of numbers multiply to be negative 24 and add to be negative 10. So we have 1 and 24, 2 times 12, 3 times 8, 4 times 6. So the option that's going to work is 2 and negative 12 if 12 is negative. So you're going to split that to be 2u minus 12u. You could also switch the order of these. It doesn't matter. But I'm going to bring down the 8u squared plus positive 2u minus 12u minus 3 equals 0. So if we factor by grouping, the greatest common factor here is 2u. We take that out of both, we're left with 4u plus 1, because 2u divided by itself is 1. Here, we're going to carry down the negative, and we're going to take out a greatest common factor of 3. And if we do that, we are also left with 4u plus 1, because negative divided by negative is a positive, and negative divided by negative is a positive. So if I continue this, my two options are 4u plus 1 and 2u minus 3 equals 0. Which means my two answers for u, if I set these both equal, would be negative 1/4 and u equals positive 3/2. But that doesn't answer the question yet. The question is asking to solve in terms of x. What we know is that u is equal to x to the 1/5. So that means that this u could be replaced with x to the 1/5 equals negative 1/4, and this u could be replaced with x to the 1/5 equals 3/2. So if I would like to solve for x, the fastest way to do that, or the reciprocal of 1 over 5, is 5 over 1. So you could raise both of these to the 5th power. So here they would cancel, and you would get x equals, because they're inverses, negative 1/4 to the 5th. So negative 1 to the 5th is negative 1, and 4 to the 5th, or 4 times itself 5 times, is 1024. So there's one answer. The second answer, if I raise both of these to the 5th, then these inverses cross out, and you're left with x equals 3 to the 5th over 2 to the 5th. So 2 to the 5th is 32, and 3 to the 5th is 243. Writing your answer as a fraction is perfectly reasonable. If you took both of these answers and plugged them back into the original problem, they both do work. My suggestion to do that would be changing them both to decimals and plugging the decimals into the original problem. Number 5, find the following information and graph this exponential equation. Y equals 4 to the x plus 2 minus 6. Please consider the parent function first and then the transformations. And so the parent function, or the most basic function here without any movement at all, is just y equals 4 to the x. The movement we're going to be dealing with, though, is if we see x plus 2, that really means eventually I'm moving to the left 2, and the minus 6 means I am moving down 6. So the parent function is the basic function without those movements. And so what I like to think about is what the parent function looks like, and then we can shift those points around. So usually the best values are negative 2, negative 1, 0, 1, 2. So if I take all of those and plug them into the parent function, I would get 16, 4, 1. Remember, negative exponents are reciprocals. So if 4 to the first is 4, 4 to the negative first must be 1/4. In the same way, if 4 to the second is 16, this would be 1/16. So 1/16 is really 0.0625, and 1/4 is really 0.25, just for future reference. So now these are my coordinates for the parent function. So now I'm going to think about what the coordinates are going to become if I do those movements left 2, down 6. So I'm going to write those new coordinates down here. If I'm going left 2, I'm going to change all my x values first. So I'm going to make 5 new coordinates here, and I'm going to go through. If I'm going left 2, that means all of these are being subtracted by 2. So we have -4, -3, -2, -1, and 0. So all my x coordinates, the transformation is taken care of. My transformation for down 6, when we start at the bottom, down 6 would be 10, would be -2, -5, -5.75, and lastly, this is -5.9375. So if I graphed all those new green points, my graph would look like this. So -4, -5.9, almost -6, would be right here. Then I have -3, -5.75, so a little bit higher. Then I have -2, -5. Then, sorry for this being in the way, -1, -2. And then very high up at 0, 10. So it looks like this is exponential growth because it's going very, very quickly. But it looks like to me that my values are getting closer and closer to -6 but not touching, which makes sense that the function is moving down 6 units. So if the parent function, there's a horizontal asymptote at y = 0, it would make sense that there is a horizontal line I can't cross here at -6 because the whole function is moving down 6. So the graph would look like this. It would be rising and then exponentially growing very to the top. Sorry that my graph's a little bit off. Easier said than done on this computer sometimes. Should be going directly through 0, 10. So now that I have my picture, I can answer my questions. My domain from left to right never ends, so it would be -infinity to +infinity. My range is restricted. It's restricted from -6 and up, and -6 is not included, so it would be a parenthesis. My asymptote is the horizontal line y = -6. I already know that my y-intercept, according to my points or my graph, is at 0, 10, so that's taken care of. But the hardest part about this problem is finding the x-intercept, and to do that, remember to find an x-intercept, y = 0. And so this is what we're going to be looking for on the test. Yes, the calculator is helpful, but we want to see if you can solve this with logs or exponents. So if the original problem is y = 4 to the x + 2 minus 6, and I know that y = 0 on the x-axis, I'd have 0 = 4 to the x + 2 minus 6. And so to solve this, I would add my 6 over and get 6 = 4 to the x + 2. If I would like to solve this equation, I could try to change these bases to be the same thing, but I can't write 6 as 2 to a power, so what I have to use is use logs instead. So you could either use log or ln. My personal favorite's ln. So we would take the natural log of both sides, because the inverse of exponents are logs. And if I do that, I'm allowed to bring this exponent down in front. So I would have ln of 6 equals x + 2 times ln of 4. And from there, your goal is to get x alone. So I would suggest dividing by ln of 4 on both sides. So you'd have x + 2 equals ln of 6 divided by ln of 4. So you'd have to subtract the 2 as the last move. So x would be equal to ln of 6 divided by ln of 4 minus 2. And if you grab your calculator and you plug this in exactly, I got this value to really be -0.708, 0. And if you look back at your graph, does it look like the graph could cross at -0.708? Yes, it seems reasonable because it crosses the x-axis about there. So the y-intercept is 0, 10, and the x-intercept is -0.708, 0, and I knew that because I use logs. So if you are on the test and you forget how to find it on your calculator, which is important, I think it's more important to be able to use logs to solve those. So this is what I know I'm going to be looking for on the test. The next problem, graph the function. This time we're graphing a log function, which is the inverse of an exponential function. we again want to consider the parent function first. Now, what I like about logs with the parent function is we have 2 points that we always use for logs. One of them is 1, 0, and the other one is the base, 1. So our 2 main points would be 1, 0, and then it would be the base of this log is 3, so it would be 3, 1. And so these would be the points of the parent function. So I'll make a note here that all of this has to do with the parent function. However, if we would like to do the transformations, so inside the parentheses is always opposite of what you think. So this function is moving to the right 3, and the y's do what you want. So the y's are really going up 2 units. So if I take these points and do exactly that, if I first go to the right 3, we would have 4 here, we'd have 7 here. And if we went up 2, we'd have 2 here and 3 here. So we'd graph these 2 points. The graph, the point 4, 2 is right there. The graph 7, 3 is right there. The point's right there. Now think about, before we graph this, what a regular parent function of a log looks like. The vertical asymptote is at x equals 0, which makes sense because if we go back to the previous problem, if the asymptote of an exponential function is a horizontal asymptote, it would make sense that the asymptote of a log function is vertical because they're inverses. So if the parent function is at 0, this graph is moving to the right 3. So it would make sense to me that the vertical asymptote moves or shifts right to 3 units, which means my graph would look something like this. It would start low, go close to the vertical asymptote, hit both points, and then increase less quickly up there. So now that I have my picture, my domain is restricted this time. We're going from 3 to infinity. The range is not restricted because we're going from negative infinity to positive infinity. The vertical asymptote is at x equals positive 3 because we're shifting 3 to the right. I do not have any intercepts yet, but I do notice from my graph that I do not have any y-intercepts. So I'm going to make a note. We have no y-intercept because it does not cross the y-axis, and I can show you why in just a second. But it looks like I do have an x-intercept, and again, it looks like it's not nice. So probably we're going to have to use exponents or logs to solve. So if I would like to find my x-intercept, that means that y equals 0. So if I look at my original problem and I plug in 0 equals log base 3 of x minus 3 plus 2. If I solve this, I have a log equation, so most likely we want to create an exponential equation. So the first thing we would do is move the 2 to the other side by subtracting it. So we'd have negative 2 equals log base 3 of x minus 3. Then if I would like to convert this to an exponential equation, the base of this log is 3. The exponent is negative 2 because logs equal exponents. So we have 3 to the negative second power equals x minus 3. And 3 to the negative second is really 1/9 equals x minus 3. 1/9 is really equivalent to 0.1 repeating, so 0.111 all right equals x minus 3. And if I add the 3 to the other side, I get 3.111 and so on. If I look at my graph, it looks like that could be possible, that the x-intercept's at 3.111. So my x-intercept, I'm going to go 3.1 repeating, 1, but I will accept 3.1, I will accept 3.11, but I'm just being careful, so that would be my x-intercept right there. If you're interested, another reason why there's no y-intercept is if you look at this original problem, and if you'd like to find the y-intercept by hand, that means x equals 0. So you could say log base 3 of 0 minus 3 plus 2. So you'd have to ask yourself log base 3 of negative 3 plus 2. This, the answer should be an exponent. So let's think about if that's possible. Is 3 to the anything equal negative 3? No, because 3 to the first is 3, 3 to the 0th is 1, 3 to the negative first is 1/3. I can never get a negative, and you might remember for some equations that I cannot plug a negative back in. So that means, that's another reason, because this is not possible, why there's no y-intercept. So even if you don't get the graph on the test, you could still prove that there's no y-intercept by using log logic or exponential logic. So there's going to be one more video going through the last couple problems. I knew these would take a while. I hope it was helpful. Thank you.